Hello, welcome to topic 6.2, homework help. Here we go. Get your calculators out. Let's get started. If two angles of one triangle are congruent to two angles of another triangle, that is all you need to show that two triangles are similar. We call that angle. Two angles of one are congruent to two angles of another, similar. Can you assume that corresponding sides and corresponding angles of any two similar triangles are congruent? Yeah. Can you? Oh, are congruent. Corresponding angles, yes. Corresponding angles will be congruent. Corresponding sides, no. Corresponding sides will be proportional. So write a little something about that. If the shapes are similar, angles will be congruent. Sides will be proportional, not congruent. All right, next. We've got some triangles. Are these two triangles similar? Well, before you get started, you need to figure out the angles. So if that's 48 and that's 90, that makes this 42. All right, now, we do have one angle that's the same, and we now have another angle that's the same. So we could use angle similarity to state that these two triangles must be similar. All right. And then here comes the similarity statement. We could say H, triangle H would have to match up with J, like that. We could say the 48, this must be a 48-degree angle, so G would match up with L. And then lastly, F would match up with K. There you have it. Hold on one second. I'll be right back.
Figure it out?
Yeah. Okay, on to, let's do number 6 together. Are these two triangles similar? Let's find out about the angles. We need to have two angles that are the same. So if I use 180 degrees, to find that angle right there, 180 minus 25 minus 73 is 82. Okay, so that's 1. They do have an A. Do they have another A? That's 25, and that's 25. So that is our other A. We can say that these triangles are similar by angle, and therefore we can then write a similarity statement. Triangle, let's start with D. D matches up with S. C would match up with U. And E would match up with T. Like that. There we have it, we matched up. All right, next, are the two triangles similar? Well, we definitely have vertical angles here. So I'm gonna say yes. By angle. We got two angles, 1 and 2. Are these two triangles similar? Well, let's see here. Because of the parallel lines, anytime you see parallel lines, you got to go back to semester 1. When you see parallel lines, you've got angles that are the same. In fact, these two are the same. They are corresponding. And these two are the same. These two. So yes, by angle again, we got two sets of angles, this and that. All right, down here, let's go to number 10. Are these two triangles the same? Well, you do have one angle that counts as an A. Because of the parallel lines, look, we can use the Z thing. We can say that this angle has to be the same as that angle. And there's our other A, so we'll say yes by angle. Okay, describe and correct the error. Look at these two shapes. We've got one set of angle. We've got another set of congruent angles. So why is it wrong to say that these shapes are similar by angle, it's because it only works with triangles. You can only use angle. You would need, you can't use angle with anything but triangles. It only works with triangles. We're only gonna do triangles actually in this class. Next, describe and correct the error in solving for x. You gotta be consistent. We're going to start with this whole length of 4 and divide it by this whole length of 6, which is why we started with 4 to 6. Now, to have the appropriate proportion, it's the whole length of this triangle. So you have to do the whole length of this triangle divided by the whole length here. So it should have been 4 is to 6 as 9 is to x. It should have been a 9 here to make that an appropriate proportion. All right, next. Complete the theorem. Let's see, you're copying complete the proportion that you will use. So based off of this, QR would match up with XY. So I can definitely put XY there. YZ would match up with RS. So I can put RS there. And QS would match up with XZ. So I can put XZ there. Notice that it's, let's call this A and call this B. Every one is A over B, A over B, A over B. All right, I'm just matching stuff up. That's all it takes for that one. All right, next one. Which one does not belong? Explain your reasoning. More than likely, I'm guessing that one of these triangles is not similar to the others. So let's see if we can figure out a scale factor. All right, if I take 3 and multiply it by 3, so if I start with this one, if I multiply it by 3, that gives me 9. If I take 4 and multiply it by 3, I get 12. If I take 6 and multiply it by 3, I get 18. These two are similar with a scale factor of 1 to 3. 1 to 3. Let's try these two. Are these two similar? If I take 3 and multiply it by 2, I get 6. If I take 4 and multiply it by 2, I get 8. And if I take 6 and multiply it by 2, I get 12. I'm guessing that this one is not similar. If I take 3 and multiply, if I add 1, no, add 2, and no. See, this, you can't multiply these to get these numbers. So this one is not similar. That's the weird one. All right, next one. It says determine whether JKL or RST is similar to ABC. So here's ABC. And so we're going to look for some type of pattern. So 7 would have to match up with 6. All right. I think we have to use multiplication and division. So 7 divided by 2 is 3.5. That works. 8 divided by 2 is 4. 12 divided by 2 is 6. It's got to be this one. This one is the proportional one to ABC. All right. Which of these two must be proportional to ABC down here in number 4? Figure that out. All right. Next, it says find the value of x that makes the triangles similar. In order to do that, I need to match some stuff up. I'm going to definitely use this to help me match some stuff up. So let's see here. DE matches up with XY. Ooh, look at that. See right there? This is a 1 to 2 ratio. I know that this triangle is double this triangle. So I really don't, I can figure this out. Or 5 is half of 10. So if this is 14, what's this have to be? It has to be 7. Use that to solve for x. Should circle it, makes it confusing. If this is 14, then this is 7. It's half of that. And then same as well. 5 times 2 is 10. 7 times 2 is 14. 11 times 2 has to be 22. All right, so solve for x there, or you could solve for x there. It doesn't matter. Either one works. Now this one, EF would match up with YZ. There again, this is a 2-to-1 ratio. This is 2 4s, this is 1 4. 10, that must make this one 5. Because that again, 10 and 5 have that same ratio. 7.5, that makes this one, well, it's double, right? So 5 times 2 is 10, 7.5 times 2 is 13. Use that to solve. There we have it. Solve for x from there. Determine whether the two triangles are similar. All right. In this one, can we make a proportion with 8 and 6? So we'd say 8 is to 6 as 12 is to 9. Is that true? Cross multiply is 72. Cross multiply is 72. I would say the sides are proportional. And they do have an included angle that's congruent. So yes, we can use what the side angle side. Remember, there's 3 ways to show similar with triangles. It's angle, angle, side, angle, side, and side, side, side. So you have to do the same thing here. Check and see if the shapes, we definitely have an angle, but are these proportional? Can you make a proportion with 8 over 10 and 18 over 24? Next one. Let's try some. In this scenario, let's do 15. Are these two triangles similar? If they are, we're going to use side, angle, side, because we do have an angle. Are these sides proportional? Well, the 21 would have to match up with the 35 since it's the smallest, and 30 would have to match up with 50. So let's see if we can make a proportion. 21 is to 35 as 30 is to 50. Okay, that just reduces to 3 over 5. That's an easy one to reduce. What does this reduce to? Divide both of them by 7. 21 divided by 7 is 3. 35 divided by 7 is 5. That does reduce to 3 to 5, which makes these proportional by side, angle, side. Error analysis, let's go down here. Describe and correct the error. They said that triangle ABC was similar to triangle PQR by side, angle, side. Well, first, let's check and see if these are actually proportional. So 15 would match up with 20, and 18 would have to match up with 24. Let's check that out. We can do a quick little cross multiplication to see if that is true. So 15 times 24 and 20 times 18, you know what, that works. 360. So that is proportional. Maybe they didn't match things up correct. All right, so maybe they didn't match things up. So B should match up with Q. That works. B is matched up with Q. The larger of the sides is matched up with C. And here the larger of the sides is matched up with P. So does C match up with P? Ooh, see, that's the problem there. This should be R, Q, P. Now they will match up. C would match up with P. It's across from the circled one here, and P is across from the circled one. So it was a matching up problem. All right, I think that's all the help you get. Enjoy, and bye-bye.